Hello again. This is the walkthrough of my filter functions for hand in 4. Um, yeah, and we start off with the median filter. Um, Now, I don't know if this line is actually correct, but I hope so. It seems so. Although it seems to be slowing down the process pretty much. Um, but whatever. Yeah. A max filter. Here I simply need the highest value of the neighborhood and replace the pixel value with that. Um, so I declare my max value. I set it to 0. If input is larger than 0, then it will become the max value. Um, yeah, or if it's bigger than max. The first time it will be 0, so if input is larger than that, max value will become equal to input, and if input then gets higher than that again, it will be equal to max value, and that will become the output value for the new image. The mean value, that's the exact opposite. That's why I set the pixel value to the maximum, and then see if mean value is larger than the input, and then give it the mean value if it's the input is smaller than the mean value, and then output will become mean value, and this seems to be working okay, fine. So yeah, no worries there. This is a Pruitt kernel, -1 on this side, +1 on this side, and the same here for the vertical and the horizontal kernels. Um, they are computed separately. So I declare a value for some vertical and some horizontal. I do the same for the both of them, using the kernel vertical and horizontal to get the different values, and then run through the kernels with the for loops here. And I check if the sum of h or the sum of v, the sum of the horizontal or the vertical, is greater than threshold, then it will become 250, else it will just become 0. Yeah, and this is the same for Sobel S detection. The difference is this is -2 and this is 2 instead of once. And the same here in the horizontal. Again, divide the sums up to 2, up into 2 values. Do the same with the computations, and then ask again if somehow some h or some v are greater than the threshold. The threshold I get from up here, parameter in my function. Yeah, and it sets again a binary image of 255s and zeros if the sum up here is above the threshold. And here we got the vertical edge detection. There I only got the vertical super kernel in, and I run it out and get an output that only detects vertical lines. Yeah, the Placian, I've done this by making some variables, as it needs to be computed in this way. It's easier to divide them up into four variables, and so these four are actually my kernel, taking my y-1, y+1, x-1, and x+1 into account, and then adding them together in the formula that I got from the book. and that's pretty much it. This is my take on an embossed filter. To be honest, I'm not really sure if it's truly an embossed filter, but you can see the result in the first video. I make a filter, and it's kind of like the Sobel or the Pruitt, but this time it detects edges at a 45-degree angle. Yeah, run through it again. Some plus or minus something times here plus minus 1 times input, and sum is equal to the output, and that's a result of them both. Dilation, I have my kernel here 3 times 3, a box filter, and run through it, checking if both the input and the filter is 1, then adding 1 to sum. If sum is greater than 1, it should be greater than 1, because one of these positions need to be 1 in order for the sum, for the output to become 255, as it only needs a hit, not a fit, to make the pixel white. And in dilation or in erosion, it's kind of like the same as in dilation. The only difference is that the sum now has to be equal to 9, so it's a fit 9, because there's 9 ones in this kernel here, and it's 3 times 3 neighborhood, so that's 9 pixels. So that's why all need to be white, and then that's why sum needs to be 9. And again, getting that binary image out on the other side. This is my grassifier, giving it an array to work with, width and height to run through it. Height is actually not really needed, because I only use width, but it has stuck, so it's just there still. And this is the X and Y positions that needs to be checked, and the marker is what the pixel will become. You can see the input is set as the marker that comes in here. Then making sure that we don't exceed the borders of the image. That will make the computer crash, and yeah, we don't want that. Then checking if the pixel is white, taking it from pushing the position x plus 1, and then taking y plus 1, x minus 1, and y minus 1, in that order. And the functions will be opened as needed. It might take a while before it gets from this statement to the next, for example, because it has to run through a lot of functions. It opens here, and then it opens a new one, a new one, a new one. Yeah, that must be pretty much the explanation of that. Yeah. And then the next one is counting pixels, the area of known blob. I make an int that's gonna count the pixels. In this case, I search for an input of 51, so that would be the first blob that I find. I should remember I set the first pixel value to 50, or 51, when burning the image out in my test CPP. So I'm searching for the first blob that will come into the image, and it has I use an off point a variable from Open Frameworks to keep track of the x and y position to get an center x and y. It's actually not really needed just to count the pixels, but it is also just stuck in there. And this one is for center mass. Now this time I return the off point variable that I have sent into it. So I get the position x and y center mass of a blob. Yeah, that was pretty much it for all of my filters. You can see most of what's going on in the code that I sent with the video with my hand in. So yeah, look through that. I might just go through. Yeah, this is what I talked about in the Graspire. I set this value to 50, and before the Graspire runs, it will be added +1 if the pixel is 255 in the image that we have set up here, and the Graspire will run with this new number that is 51, and that's why I'm searching for the 51 blob. Yeah, that's pretty much it for this hand-in. Enjoy your half an hour or so video. Yeah, bye.